Harry, there, geometries. In this lecture, again, this is going to be a real short lecture. That's kind of your favorite kind, except the in-person variety when you get to see me, stand in front of the room. But in this lecture, this is following section 6.5 in your book, and it's conditions for special parallelograms. So you've already got all these theorems in your notes, and what we're saying is, hey, if a parallelogram has one right angle, then it's got to be a rectangle. Another one is, if a parallelogram has congruent diagonals, then it's also a rectangle. So how this plays out is you're going to get problems that look a little different. And this one says a manufacturer builds a mold for a desktop so that AB, which over here, is congruent to CD, and BC congruent to DA. Okay, great. Well, and the measure of ABC is 90 degrees. Hey everybody, that was great. She just came in and looked at this problem and said, well, Mr. Rising, doesn't that have to be a rectangle? Because, of course, my opposite sides are congruent, which means number one, it's a parallelogram. And then number two, just on that new theorem you saw, if one of these angles is a right angle, then it has to be a rectangle. Very good, Grace. Way to go. All right, take a look at this one. This is one that you are going to answer on your own, and you're going to show me on the next day that we get together and meet. So pause the video and write out your solution. The next set of theorems has to do with rhombuses. Again, I say rhombi because that's what I was taught. And anyway, so here we go. If one pair of consecutive sides of a parallelogram are congruent, that would make all four sides congruent, right? Therefore, it's a rhombus. The next one, diagonals are perpendicular. And again, you know it's a parallelogram. It's got to be a rhombus. And the last one is, again, if it's a parallelogram and the diagonals bisect the opposite angles, then it has to be a parallelogram. So what does this look like? Well, take a look here. Determine if the conclusion is valid. If not, tell what additional pieces of information are needed to make it valid. So it says given EF is congruent to FG. So let's label it EF and FG. Ooh, I like that. Okay, I've got some congruent sides looking like a rhombus. EG perpendicular to FH. Oh, sweet. Conclusion, it's got to be a rhombus. No, wait a minute. There's something wrong here because, number one, I don't know that that is a parallelogram. And I think that's what it's going to show you here as well. Right? So when you take a look at this explanation, I need to know that these other sides are congruent as well. Then, when I have opposite sides congruent, I know it's a parallelogram. But until I get a little bit more information, I don't even know it's a parallelogram, let alone that it's a rhombus. Problem number 2, to put in your notes and solve, and see if you can do it right before the class, the next class that we meet. All right, the last one here, I'm actually going to go step over to the board and work this out because using the mouse to write is just a horrible idea. But it says, use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all the names that apply. So it could be none, it could be more than one. So step number 1, I'm going to plot the points. Step number 2, I need to find the length of the diagonals. And then step number 3, I'm going to find the slope of the diagonals. So actually, this is a much easier problem than it looks. So I'm gonna talk nice and loud so you can hear me. If you can't hear me, I guess turn up the volume because I got to work at the board. So when I go from these points here, you can see that the slope goes down 1, and then 1, 2, 3, 4, 5. So this slope from here to here is down 1 over 5. Now what, I guess I should have labeled that. That would have been pretty helpful. So this is going to be P Okay, so the slope of PR equals -1/5, right? And the slope of QS, here I'm going to go 1, 2, 3, 4, 5, up 5 over 1. So this one is up 5 over 1. Notice the slope of the diagonals here. These are opposite reciprocals. Recip, which means that they are parallel. Okay? So number one, the slopes of the diagonals are parallel. Now that I've done the slope, I'm going to just jump on here for a second. I'm going to connect these two using my fancy tools. Now, I already have the rise and the run. So what's so helpful there is when I need to find the length of these, well, it's the square root of 1 squared plus 5 squared. And that is the square root of 26. Well, you know, this one is also the square root of 1 squared plus 5 squared, and that's the square root of 26. By doing the slope first, essentially what I end up doing is making right triangles. And that gives me the side length or the legs of those right triangles. And from that information, then I'm able to use the distance formula or the Pythagorean theorem to figure out what the length of those diagonals are. So that's probably the easiest way to do these kind of problems is, first of all, plot the points. And I should rewrite this. I should say find the slope of the diagonals, because I'll use that same information here to figure out what the length of the diagonals are. Now, I haven't fully answered the question. Okay? So, number one, is it a rectangle? Well, yes. The reason it's a rectangle is, and I'll pull out a little highlighter here, it is a rectangle because the diagonals are congruent. Sweet. Is it a rhombus? Yes, it's a rhombus because the diagonals are perpendicular, and that means if it's a rectangle and a rhombus, then I know it's a square. Let's see how you feel about this problem right here. So you're going to do the same sort of process. You're going to try this problem out, do it in your notes on your own, and we will check your answers when we meet in class next time. Hey, guess what? That's all. You guys have a good week, and I'll see you in class.